Let's start from the Zendoo part, and in particular on the certificate quality. So, as was already mentioned some weeks ago, we started working on the, let's say, introduction of the changes that are needed for testing the quality while receiving certificates in Mange. So we need, just to make a very simple example, if we have a fork in the sidechain and then we have to provide a certificate in Mange, which will be the certificate that should be adopted. So we have a time window for accepting them, but let's say that in any case there could be some conflicting certificates, and so we have this concept of, let me say, general concept of qualities. And in the previous beta version was not managed, this quality parameter, and now we are implementing it by adding all the logic that is necessary for, let me say, deciding which certificate should win, how we manage, for example, in the same block, two certificates with different qualities, and so on. So currently, this task, currently we have identified, we made a detailed analysis on how this could be, can be implemented in Mange, what are the changes needed. And after this analysis, we ended up with a list of tasks, and so currently the guys are working on it for Python tests, integration tests, and also unit tests, and also the implementation itself in the various parts. Okay, this was about the certificate quality. Regarding that Zendoo cross-chain transfer protocol lib, do you remember is the library that is, let me say, including the cross-chain transfer protocol implementation in Rust that are common both to the sidechain and mainchain. So that are not meant to finish in Ginger. So this is something that is still going on, and we expect to have soon it finished. Regarding the, so let's switch from Zendoo to the proving system, and what regards the proving system itself, the GPU optimization, the proof workshops, and so on. So as we mentioned, we are going on with some detailed analysis on possible improvements that we can do on Marlin to speed up, to have let me say, a significant speed up for it. So we already, I mentioned previously a paper that was written for it, detailed analysis, and then, but now we are working on to verify really the feasibility of some possible improvements. There was the need of doing some tests, okay, let's say coding tests. So, for example, Daniela is working on some requests from Murish to be able to have some, let me say, computation that needs to be done to understand really what if what we imagine is feasible and what would be a possible implementation for it. So this is something that is going on. Okay, regarding the GPU optimizations, we have been able to implement the MSM via GPU also for Marlin. We have been able to run some performance tests on a whole Marlin proof. So with some test circuit, we created some test circuits. We created then some benchmarks that were, let me say, comparing the performances of Marlin proving performances using GPU and using CPU, just CPU. So, but this was the performance improvement was just about MSM, and so. But there is another part that can be that can have also a relevant impact on performance, that is FFT, and also this FFT can be improved on GPU. So currently we are working also on that, and after having poured also that part on GPU, we will be able to have a whole Marlin proof performance comparison between GPU and CPU. And also we will normalize these values, these improvements by cost, because in reality, what you really want to have is to have a comparison between costs. So let me say, for example, a server that is using CPU has some cost, and with the same cost, another using GPU, and so then you will be able to really compare the two performances. Okay, regarding instead of proof workshops, we are going on with this proof workshop where we, let me say, see in details what we need to prove for each transaction, and so on, and what are the impacts on the SDK and on the circuits. So this is a key activity, because this is the activity that lets us identify the tasks that are, let me say, that we will work on for the next months. So it's a very key element, and also provide us ways also for let me say, looking also in detail about the design of the circuits, and how we can, for example, make them extendable. So if we need to prove something specific for some specific sidechain, and so on. So long story short, these proof workshops are going very well. And for example, this morning we had another one, and we have been able to, let me say, roughly describe how we can create the base transaction circuit that can be then extended and expanded for additional purposes. And we have identified also the impacts on the SDK side that let me say, this could that are necessary. Obviously, we will proceed also with this workshop. I mean, tomorrow morning we have another one. Okay, let's switch on the latest decentralized actors reward model. As you know, we have been working on these decentralized schemes for rewarding the actors in the sidechain, and so we wrote a paper that is not yet published, but we have been also working on a game theory analysis for it. So we want to prove that the system was able to converge the proof price to, let me say, the cost, let me say, plus some margin. This is obviously the best scenario that we can have. So these game theory analysis has been done. It's a very, let me say, complex math analysis on it, and we had a presentation for it, and currently we are going through it and understand. We are in the middle of the document, so we are going on and understanding what are the results, but so far everything seems very promising. So it seems that the scheme is providing, let me say, what we expected to have. Okay, totally different topic. Halving. We will have the halving in about a couple of weeks. So as you know, we have implemented all the unit tests, and the first code review was already being done. And today I made the last remaining code review, and so everything seems okay. And so this is approved. For what regards ND, just another thing we are working on a way for increasing the reindex performance, the reindex switch performance. No, so if you run reindex on ZenD, currently is really too slow. So so we identified some interesting improvements that we can have, and so currently we're working on it, and I'm quite positive that this will provide very strong improvements. And I mean, probably was not short, sorry, but many things we are working.